Hello, I'm Merrilee Thomas. I'm currently a postdoc in Marina Picciotto's lab at Yale University. I'm going to be sharing my PhD thesis work with you today that I did at Montana State University under Tom Hughes. Imaging of neuronal activity. The signature biochemical changes most widely used for optical imaging include changes in the concentration of cytosolic calcium ions and changes in membrane voltage. We will focus on calcium and voltage changes using genetically encoded voltage and calcium sensors. Voltage sensors are transmembrane sensors that are fluorescent proteins which are attached to voltage-sensitive proteins, and recorded changes in voltage result in changes in fluorescence. Calcium sensors are sensors that sense calcium ions in the cell and change their fluorescence in response to cytosolic calcium. We need better ones and faster ones that are brighter, and currently that involves making prototypes and testing them. My goal was to turn an unresponsive fibroblast into a pseudoneuron. I wanted to create an action potential in this synthetic biological circuit, and by using 5 different genes, I am able to optically stimulate the system with light while being able to record the activity within inside the system. So why is this pseudoneuron useful? Imagine that you have invented a new red fluorescent sensor. How would you know if it's better than the existing green sensor? To see if we could quantitatively benchmark one sensor against the other, we used an optical splitter, as you can see in the image here, to compare the responses of activity in the same cell using R-gecko and G-gecko. We can measure these responses easily using tau on and off. By using this high throughput system, we can test novel sensors against the current gold standard. To reiterate, I have made inert hex cells into pseudoneurons by creating a synthetic system which I can activate with light. My system, the cool system, is extremely reproducible and tunable. I can adjust the amounts of KIR and NAV to create slower or faster calcium transients, and I can also use different cyclic AMP gated channels, such as CNG or HCN2. I have shown that screening green and red calcium and voltage sensors is possible. In theory, this system could be used to not only test many prototype sensors, but to also screen thousands of compounds for drug companies by changing out the channels. For example, I could screen heart drugs or sodium channel blockers. Thank you for your time.